We are going to see one topic from the self-study section, which is going to be DC machines and DC motor. Okay. To start with, let us understand the classification of DC machine first. Now basically DC machine can be either DC generator or DC motor, both. So we have already seen what is DC generator, how does it act. Now after this classification we are going to understand the working of DC motor also. Fine. So first let us understand how these machines are classified. Okay, and for your information, let me tell you that any DC machine can act as a generator also and as a motor also. Fine, so this classification is applicable for both generator as well as motor. So the first type of DC machine is separately excited DC machine. Now how are they classified? Now this classification is on the basis of their field excitation method. Now what is the meaning of field excitation? Now you have two types of windings in any DC machines. One is called the armature winding, okay, and second is called the field winding. Now armature winding, we know what is armature, right? It is the coil which is kept between the magnets, which actually rotates, or which is rotated in case of generator, and in case of motor it rotates. What is field winding? Now field winding is used to make electromagnetic working. It means that in order to excite the electromagnet, we use field winding. So first is separately excited DC machine. Now here the field winding is supplied from a separate power source. Okay, it means that the field winding is electrically separated from the armature circuit. So there is no connection between the field magnets and the armature. Okay, but this type is very expensive, and secondly this type of DC machine is used in laboratory or research work. Okay, now let us come to the second part. The second type is known as self-excited DC machine. Now in this type the field winding and armature windings are interconnected in various ways. Now in what ways, that we are going to see after this. Now self-excited DC generator, the field winding is energized by the current which is produced inside them. Okay, so there is no separate source which is used to excite the field winding. So whatever current is produced, the same current is used to excite the field magnet. Fine. You can see that here, see, this is the voltage regulator. Okay, this is the voltage regulator. Fine, and you can see that armature and field windings are connected together, whereas here there are no connections, so they are electrically isolated. Fine. Now again let us see how self-excited DC machines are classified. So self-excited DC machines are classified into three: series wound DC machines, shunt wound DC machines, and compound wound DC machines. So let us first see what is meant by series wound DC machine and shunt wound DC machine. Now we all are familiar with the series connection, and we also understand what is the meaning of shunt. So keeping that concept in mind, if you look at the figure, you will understand that here the field winding and the armature both are connected in series, right? Only one ends of each are connected together. And here they are connected in shunt. So both the ends are connected together, isn't it? So this is how series and shunt wound DC machines look like. Okay, now we come to the third type. Now we have seen that either the armature and field windings were having series connection or they were having parallel connection. Now what is the meaning of compound wound? That it will have series as well as parallel connection. Okay, so both type of connections will be there. Now how? So again it is classified into two, long shunt and short shunt. Now what is the meaning of long shunt? Now if you see in long shunt, the field winding is connected in parallel with the combination of series field winding and the armature winding itself. It means this is the series field winding, right? And this is armature. So there is a series connection also, and this shunt field is connected in parallel with this combination, which is a series combination. So here you have shunt also, you have series also. That is why the name is given as compound DC machine. And long shunt because the shunt field is in shunt with the series combination. Okay, now this will be more clear when you see the short shunt compound DC machine. Now in short shunt DC machine, you can see that here the field winding is connected in parallel with only armature winding. Correct? So here you can see that this is the shunt winding and this is the armature winding, and series field is here. So it is not in parallel with the shunt field, right? Now when you compare both these diagrams, you will understand what is the difference between the two. Fine. I hope this is clear to you. Secondly, let me just tell you what all parameters are mentioned here. Now here the load is connected at the output. Okay. And SH is the shunt current, IL is the load current, and SE signifies series. Fine. Now let us understand the working of DC motor. So how does DC motor operates? Basically, what exactly is the meaning of DC motor? Now we saw that generator is a device which converts mechanical energy into electrical energy, isn't it? So DC motor is exactly opposite. So DC motor is a device which converts electrical energy into mechanical energy. So when you supply electrical energy to it, the armature starts rotating. Fine. So if I try to tell you how the connection is done. So here you have north pole, here you have south pole. So this is the magnet. Okay. And here you have the armature coil. Fine. So there we used to generate electrical energy. Here we will give electrical energy. So current flows. Fine. And when the current flows through armature coil, magnetic field is produced, isn't it? And there is a magnetic field between this magnet as well. So these two magnetic fields, they interfere with each other and a torque is produced. Okay. And that torque causes this armature coil to rotate, and it starts rotating. It means in this way we convert the electrical energy into mechanical energy. Fine. And secondly, the force experienced can be given by F is equal to B I L. Okay. Fine. Next, let us understand what is the arrangement of this DC motor. Okay. Now you can see that north pole, south pole, it means magnets are shown, right? And the armature coil is also shown. Now, where is the armature coil here? This is the armature. Okay. And these plus and dots, these signifies the windings. Fine. Now, when you talk about what is the meaning of this plus or say cross, that is also known as cross. So what is the meaning of that? The meaning of cross is that current is flowing in downward direction, or in this case you can say that it is going inside our screen. Then what is the meaning of dot? Dot signifies that the current is flowing upwards or it is coming out of the screen. Fine. It means that in half of the windings the current is flowing inside the screen, and in half of the winding the current is flowing from the screen. It is coming from the screen. Fine. Okay. Now what happens? As I've already explained, there is a magnetic field because of the electromagnets, that is north and south pole. And when this current flows through the armature winding, it again starts inducing the magnetic field, right? So these two magnetic fields, they interfere with each other and the torque is produced. And in this torque, you see these arrows, right? So these arrows signify the direction in which the armature starts rotating, which is anti-clockwise. Okay, so my armature starts rotating in anti-clockwise direction. So here also we have commutator, here also we have brush. In fact, the construction is exactly the same as it was in the case of DC generator. Fine. Now here this torque. Now what is torque? Torque can be represented as the product of the force experienced and the radius at which the torque is acting. And what is the unit? The unit is Newton meter. The unit of torque is Newton meter. So in this way, the armature starts rotating. Okay, I hope you understood till now. Now let us understand a very important topic, which is back EMF. Now you should understand that whenever energy conversion takes place, whether it is electrical to mechanical or mechanical to electrical, there has to be some kind of opposition. Otherwise, this energy conversion is not possible. Now what happens in case of DC motor? In case of DC motor, we are making the current to flow through armature winding, because of which the armature starts rotating, right? Now, please remember that there is already a magnetic field present because of the electromagnet. Now, when we study generator, we know that whenever a conductor cuts the magnetic field, again EMF is induced due to Faraday's law of electromagnetic induction. Now, here what is happening? Because of the two fields produced, a torque is produced and the armature starts rotating. But when it starts rotating, it cuts the magnetic field which is already there. So in this process, again an EMF is induced, right? But that EMF is in the opposite direction. Fine. It means it reduces or opposes the EMF which is already present in the circuit. Now, since it opposes, it is this type of EMF is known as back EMF. Now, this back EMF is actually responsible for the generation of, rather I would say conversion of electrical energy into mechanical energy. So this back EMF is very much important for us to understand. Okay. So how do we represent this back EMF? So here you can see that in this, see, this symbol is actually for armature. Okay. So this is armature. Fine. So here you can see that back EMF is represented by IB and armature resistance is given, which is assumed to be RA, and you have shunt field also. The equivalent circuit of back EMF is shown in this figure. So you have armature current, right? So this is armature current flowing. This is the armature resistance and this is the voltage. So this is how back EMF is represented, right? Equivalent circuit. Now when you have to write the equation of DC motor is same as that of the generator. Fine. And this voltage, if you apply KVL, okay, so by applying KVL also we can arrive at this equation. Fine. So when you apply KVL, you get V is equal to EB plus IA RA. Whereas V is the armature voltage, EB is the back EMF, RA is the armature resistance and IA is the armature current. Fine. Now if we wish to calculate the power, how do we calculate the power? Power is the product of voltage and current. So when we multiply this equation by IA, we get the power. Fine. So the new equation, which is the power equation, will be this. Fine. Now here V into IA. This product represents the power which is the input power to the armature. The power which is EBIA, it is the electrical equivalent of the mechanical power which gets developed inside the armature. And IA square RA represents the copper loss in the armature. Remember we studied the losses at the time of generator. So same losses are applicable in DC motor also. And here also I square RA represents the copper loss. Fine. So this is how the back EMF is represented. Now if you remember, the same equation was there in case of generator also. So same is applicable here as well. Fine. Now you have condition for maximum power, which is the maximum power is developed when EB becomes equal to half of the applied voltage. So it means that maximum power is generated from DC motor when this back EMF is half of the applied voltage. Okay. Now this is just for theory's sake. Practically it is not possible.